Students, we are given this question. Find by integration the volume of the solid generated by revolving above the y-axis, the region bounded between the curves y equal to 3 over 4 times root of x squared negative 16 and x greater than equal to 4, and the lines y is equal to 1 and y is equal to 6. So what we are going to be doing is we would be first simplifying this. So we are given this. We would want to know what curve is this. So y is equal to 3 over 4 root of x squared negative 16. This is what is given here. So we square both sides. So squaring both sides, we get. So what happens when we square? So this is going to be y squared is equal to 3 over 4 squared times root of x squared negative 16 square, which is equal to 9 divided by 16 times x squared negative 16. So if I were to rewrite this as y squared divided by 9 over 16 is equal to x squared negative 16, and then I am going to be rewriting this as, if I move x squared this side, then it would be negative x squared positive y squared divided by 9 over 16 is equal to negative 16. Okay, I can now divide by negative 16. If I do that, I would get x squared with a positive sign divided by 16. Now this is actually 9 over 16. So what I'm going to do, I'm going to rewrite it as 16 over 9 times y squared. I'm multiplying, in fact, the denominator by 16. So it's going to be something like this. And on the right side, I'm multiplying, or I would say dividing by negative 16. So it's going to be negative 16 divided by negative 16. Okay. So this is what you will get. So these can be cancelled. You can also cancel the 16 there. So this in turn would be x squared divided by 16 negative y squared divided by 9 is equal to positive 1. Because clearly the two negatives, they can be cancelled, right? So the positive sign would occur there. So this is what you get. So this is actually an hyperbola. So if you were to draw the hyperbola, so you would have a form something like this. Okay. Now you're given lines y is equal to 1. This is y is equal to 1 and y is equal to 6. So this is a rough diagram. This is your x-axis. This is your y-axis. This is the origin. So you are asked to revolve this hyperbola portion and find the volume of that revolved portion. Now the variants are given for y. So the required volume in this case would be pi times y varies from a to b, and instead of writing y squared, we would have to write x squared times dy. So we need to obtain the quantity of x squared over here. So how do we do that? So let me use this space over here. So we know that x squared divided by 16 negative y squared divided by 9 is equal to 1. So I move this onto the other side. That would give me x squared over 16 is equal to 1 positive y squared divided by 9. I take the LCM as 9. This would give me 9 positive y squared. I've got x squared over 16 over here. So you move the 16 onto the right side. That would give me x squared is equal to 16 divided by 9 times 9 positive y squared. So this is what I have got for x squared. So I need to substitute that there. So this is equal to pi times integral. Y is given to be as 1 to 6. X squared is going to be 16 divided by 9 times 9 positive y squared times dy. I can rewrite this as 16 pi divided by 9 integral 1 to 6 9 positive y squared times dy. This can be rewritten as 16 pi divided by 9. You can open a parenthesis and write this as integral 1 to 9 1 to 6, 9 dy, positive integral 1 to 6 y square times dy, close the parenthesis. So this is equal to 16 pi divided by 9. Integral 9 dy will give you 9y. That has to be substituted within the limits 1 to 6 positive. Now integration of y squared will give you y power 3 divided by 3 with the limits being 1 to 6. So this is what you have got. This is equal to 16 pi over 9. 9 of, substitute the upper limit, subtract the lower limit, you get this, followed by, in this case going to be 1 over 3, substitute the upper limit, it's going to be 6 cubed, followed by subtraction of the lower limit, 1 cubed. So this is what you have got. Now this is equal to 16 pi divided by 9, open the parenthesis, this is going to be 45, followed by 1 over 3 times 6 cubed. 6 times 6 will give you 36, multiplied by 6, 6 times 6 is 36, 3, 18, 19, 20, 21, 216, minus 1. Okay, this is equal to 16 pi divided by 9, 45 positive, this is going to be 215, okay, 215 divided by 3. I take 3 as the LCM, okay, so that is going to be equal to 16 pi divided by 9. If I take 3 as the LCM, this is going to be 15, 1, 12, 1 third, 135 added with 215. So if you were to add 135 with 215, you will get 10, carry 1, 4 and 5 and 350. So this is going to be equal to 16 pi divided by 9 of 350 divided by 3. I can multiply 9 with 3, rewrite it as 27, and in the numerator you got 16 pi times 350. So multiply 350 by 16. So 6 times 5, 33, 18, 19, 20, 21. 5 ones are 5 and 3. So this is 0, 6 and 5. You got a 0 placed there. So this is equal to 5600 and pi. So since we are dealing with the volume, therefore required volume is equal to 5600 pi divided by 27 cubic units. Okay, so that is the final answer to the question.